will study a new topic. It's the input and output devices. So these input and output devices are typically interfaced with a microprocessor-based system or a microcontroller-based system. It can be classified into three categories. The first category is a human-readable device. Then there is a machine-readable device, and there is a communication device. So what's a human-readable device? In a human-readable devices, these are the devices that can be interfaced. That is like with which the user Okay. So the human-readable device, the human interacts with the system. The human interact with the system through human-readable devices. What are the classical examples? Keyboard, keypad, mouse, okay, monitor. Monitor is also like he can view the screen and like it's human-readable. Okay. Other category of devices are machine-readable. Machine-readable. Now you have an ATM card. When you push the ATM card into the ATM, and ATM, it reads the data. If you have barcodes or e-tags, electronic tags, let's assume when a car passes through the toll plaza, okay, so it has some information. So that machine reads that machine specific information. Okay, so this is called machine readable. Human cannot read it. You cannot read it. What's the e-tag? What's the barcode or barcode detector? Okay, the barcode. Now let's assume if you have a barcode on any item, and you know when it says, it will identify the particular item, and then it will allocate the particular price. So it's a machine readable device. Another is called as communication device. Communication device, what is the classical example? Modem, Wi-Fi, okay, Bluetooth device, GPS. So these are the examples. So if we categorize from these perspectives, so it can be classified into even human readable, which human can interact with the system through human readable devices, and machine readable device, that machine read specific information from the devices, the necessary and specific information from the device, which is useful for an operation. And then communication device, like in communication device in which you send some data from your device. Now let's assume if you have a mobile and now you have a Wi-Fi. So actually you are accessing some data from where? From the servers. From which servers? Maybe from Yahoo server, maybe from Facebook server.
Yes, sir.
So these are different servers, and you can access the data. And from what are different type of communication devices that are present in a mobile? Which kind of devices? Bluetooth, Wi-Fi, GPS, mobile data. Okay, so these are the type of communication device. If you look it up at the structure of the I/O device. So now this is the structure of an I/O device. Within any particular devices, there is some data registers, and there are some control registers, and then there is some I/O logic. The I/O logic is a complex finite state machine that controls the operation of the devices, and it also has, these devices have also some interface. So this part of the I/O module. So now you have an I/O device of I/O module. This part of the I/O module interacts with whom? This part, data register and control register.
ये processor.
It interacts with microprocessor. And this part interacts with whom?
जो I/O devices.
Device. So now we have two parts. One is CPU communication. Another is
Device communication.
So these are the interfaces with the actual device, and these are the interface with the
Microprocessor.
So now you have two types of communication. One is the communication with the microprocessor. Let's assume microprocessor or microcontroller instruct the device to perform a particular operation.
Yes, sir.
So how it will control it? It will control it through the data register, control register, and there is some I logic within this. And now you have some external device interface, and it will check the status of the device. Okay, now why we have separated this portion and this portion. Why? Why you have separated these? Why you have separated?
Human intellect kरेगा.
No, it's not. It's not interacting with the human. It's interacting with the device, actual device. It's interacting with the actual device and it's interacting with the microcontroller or microprocessor. Maybe it's interacting with the, but even if you have interacting with the device, now if you look at in any kind of embedded system, now you have some sensors.
Yes, sir.
Sensor gets the information
Yes, sir.
from the environment. This data is analog or digital?
Analog.
Analog. Can my process analog data?
No, sir.
No. Now I'm just giving you an example. Now let's say you have a sensor, this analog information. Now you convert this information into
Digital.
digital information. So you need some digital
Analog ADC.
ADC, analog
Yes,
to
sir.
digital converter. It will, because microprocessor cannot process the analog data.
Yes,
So actually this is okay. Now this is one example. So now you have some sensor, analog to digital information, and it's digital data, and this digital data will go to some data register or control.
Yes, sir.
Yes, sir. And microprocessor can read from data register. This is one
Yes, sir.
example.
Yes, sir.
This is one example. Okay, so and typically devices are slow. If you look at the devices are slow. Now I will bring you another example. I will give you different example of different I/O devices. Now let's assume you have a hard disk.
Yes, sir.
Hard disk is also a device. It's input device, the hard output device.
Storage
The
device.
storage it is even an input device. It's also an output device.
Yes, sir.
When you want to read from the hard disk, then it's an input device. When you write to that, it's an
Output
output
device.
device. Now if you look at the hard disk, in any hard disk, if we divide it into different tracks, if you remember tracks and sector, you remember?
Yes, sir.
Now,
Trades.
tracks and sector. And actually the hardware, it will rotate, so there will be some motor. So this interface and controls are for these motors. Okay, now this I/O device is slow or fast?
Slow.
Slow compared to microprocessor.
Yes, sir.
Compared to microprocessor, it's very slow. So actually, it provides the communication between the microprocessor and the external device. The device, it can be in the hard disk. If you look at the hard disk, so actually there is some I/O logic that will transform that read or write command to a particular address, to a particular track in a particular sector. Now if you look at the map, let's look if you want to map. Now if you have a hard disk, now you have a hard disk. Hard disk. It's a hard disk.
Yes, sir.
Okay, and now this is the address space of the hard disk. So now let's do we divide it into different page. Page 0, page 1, page 2, page 3, and let's assume page n. If you want to access page n, so this page has some page address. This has a
Trades.
page address. Let's assume this address is 0, this address is 1, this address is 0, so this address will be n. But if you look from this page will be actually stored in some particular sector of a particular track.
Okay.
So now let's assume maybe this page is stored here. Page n. And now let's assume your current location of the read write head is here. What it needs to do? It will first move to the desired sector and then it will rotate. So all of this mechanism is done by this external device interface. From the microprocessor, if microprocessor want to read some data or microcontroller or the device controller, so it wants to read some page. So actually this data will be actually translated into particular sector and particular track.
Yes, sir.
And when it wants to read the data, so actually now, so CPU communications. CPU will instruct the I device that I want some data. I want some data. Whether I want to read the data, I want to write the data. Depending on the type of the device, whether it's an input device or an output device. There are two types of flows. Maybe there is if you look at the keypad.
So you one flow है.
So it's one flow. So the keypad will give the information. Okay, now it has some key.
Yes, sir.
So microprocessor will be interactive.
Yes, sir.
It will put the data in the buffer of the keypad. When microprocessor is ready, microprocessor will get that data from the keypad and then it will process that data. Depending on the application. Achha, yeah. Let's assume if you turn on your computer and you are typing some keys, will that keys will be displayed?
No, sir.
Why it will not be displayed?
उनके भी ऑपरेटिंग सिस्टम लोड ही नहीं हुआ.
No. If you click on some text box
Yes,
and
sir.
then you type, then it will be. That text box will become then active.
Yes, sir.
Active. When active, so then the microprocessor will communicate with the device. Oh, I want to read some data from you. If you have some data, give it to me. And when you press some keypad, it will go into the buffer. So this is called as data buffering. This data buffering is within the I/O device. When this buffer is full, it will inform the microprocessor, now I have some data, and then microprocessor will read the data from the buffer. Okay, and now error detection. There are a lot of devices which has some errors. Errors may occur due to various factors. There can be some permanent errors or manufacturing errors, or there can also be some environmental errors. I will explain this with an example. Now let's assume you have this device in its memory and some data is stored 0, 1, 0, 0, 1, 0, 1, 0, 1, 1. Let's assume this is a chart-based memory. When an alpha particle falls here, so it will change its value from 0 to 1. So now the data becomes corrected. How you can detect and correct an error?
Check some parity.
Yeah, check some. You can have some parity codes. कौन से parity error codes are there? Odd parity,
Even parity.
even parity. So odd parity or even parity, it's an error detection mechanism or error correction mechanism.
Error detection.
Error detection. It cannot correct the data. And if you have single error correction, double error, SIGDEC. So it can correct a
Single
error and detect
double errors.
double errors. If we have double error correction and triple error
Detection.
this is another. It depends on the checksum policies, and you may have studied these policies in your different courses. Okay, I'm not going into more and more detail. So this error detection is also provided by the devices. Okay, in control and timing. Why control and timing? Why control and timing is important? It coordinates the flow of the traffic between the internal resources and the external devices. The flow of the traffic between the external resources.
And
What is external resources here?
I/O devices.
From the perspective of artists, these are tracks and sectors. And internal resources. What are the internal resources?
Data register.
Data register, control register, and so it provides controls and timing. And typically devices are slow.
Yes, sir.
So then it communicates CPU communication. If you look at the CPU communication, so communication involves the following. The I/O module accepts the commands from the CPU. CPU instructs the I/O device, okay, I want a read operation or a
Right.
write operation. Then the I/O module accepts the commands from the CPU and it performs the intended operation. It can either perform a read operation or a
Write
it
operation.
depending on the type of operation. Whether the I/O device is an input device or an
Output
device. Okay? So it can be, if you look from the perspective of the I/O device, so it can be either a read operation or a write operation. So for control register, you can have like a read operation or write operation. It can also be control operation. So it can be either a read operation or write. And there are some status registers. So there is also some register that is called a status register. And this status register will tell the status of the I/O device, that whether the status is busy or ready. Now let's see. Microprocessor wants some data from the hard disk. Okay, it is not on the desired track and the desired sector. So in that case, when microprocessor wants it, I want the data from page N, which is located at sector J
Up track this.
of track K. Now you have to move to sector J and track
Check.
K. So in this case, when microprocessor instruct I want page N, so actually the device is ready or not ready?
Not ready.
Not ready. So it means it will put its status register to 0. So this status register, microprocessor will inform the status register. It will tell the microprocessor, no, my status is not ready. I am not able to provide the data immediately. Microprocessor can perform some other tasks,
Yes.
some other useful tasks. And when that page, so actually now there will be some, now it will do some device communication. This IO logic will communicate with this external device interface. And it will communicate with this. So actually, if you look at these devices, there will be some devices, there will be some motors. Now if you have this motor and this motor, so actually it will move the motor. There will be some revolution for motor. So it will rotate the motor.
Yes,
Then
sir.
it will locate on a particular track.
Check.
Then it will locate on a particular
Sector.
sector. When it's there,
Then it will be ready.
then it will read the data, and then it will buffer the data.
Yes, sir.
It will buffer the data. When the buffer is available, so the buffer is available. When the buffer is available, so from the buffer it will go to the data registers. So the data register can be a single register or it can be
Multiple
multiple registers. It can be a single register or a multiple register. Now, it also depends upon. Now let's assume a scenario. Now you have an LCD. This is an input device or output device?
Output
Output
device.
device. Okay. Now there can be a single control register or multiple control registers.
Single.
There can be a single control register or
Multiple.
multiple control register. What can be different features of an LCD? If you look from the LCD, what can be different features of LCD?
Resolution.
क्या मोड्स हो सकते हैं? You may have studied LCD during your bachelor project or जी LCD के क्या मोड्स हो सकते हैं?
मोड्स का क्या मतलब है सर?
किस मोड में LCD ऑपरेट हो सकता है? Okay, I will explain this. Okay, there can be a 2-row mode or a single row mode.
Yes, sir.
2-row mode. So if we say 2-row mode or
Single room.
single row mode. Okay, so in a 2-row mode, more characters can be displayed. In a single row mode,
Less correct.
less characters can be displayed. Okay, now if you look at here, now let's assume. Now let's say we are in LCD. We have the same LCD, and we have configured in a 2-row mode. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
12.
How many digits can be displayed on this LCD? Maximum
12.
12. Okay, so now maximum 12 1 bit. So actually, how many data registers? Maybe there will be 12 data registers. DR0, DR1 up to
DR11.
DR11. So if the value here will be displayed here, the value here will be displayed
Here.
here and some here. So there are multiple data registers. Okay, now if you are in a single row mode, if you are in a 2-row mode and DR11 it will be displayed here. But if you are in a single row mode, maybe in a single row mode you are displaying 1, 2, 3, 4, 5 and 6. How many characters can be displayed? 6. Maximum 6. So maximum 6. So actually it will only read from DR0 to
DR5.
DR5. So now there are 2 modes. Maybe there is some control register. Now this is a control register. This is a control register. And there is one bit, the first bit, maybe the first bit, MSB. If it is 0, it is multi-row mode. If it is 1, it is single row mode. It will determine the mode. Now, what can be other features? Now, if you look at the pixels. Now this is now there are 2 levels of information. This data register is from the perspective of the microprocessor. From the perspective of microprocessor. Now, what is the perspective of microprocessor? Now let's assume if we say that if we write 65 to this data register, data DR0, 65, which character will be displayed?
6.
65.
5 डिस्प्ले होगा.
A, very good. Why A? It is ASCII value of A.
की value है.
Maybe DR5 is 66, then which character will display?
B.
B, and so forth. So on. Maybe. So now this is the perspective of the data register from the perspective of a microprocessor. Now, but now if you look at the more complexity, now we have some internal device interface. Now if you look at this characters, if you look at some particular character, it consists of pixels. Now if you look at these pixels, so the pixels will look like this. Agreed?
Yes.
If you want to display A, so this pixel will be enabled, this will be enabled, this will be enabled, this will be enabled, this.
Yes, sir.
Am I right or not?
Yes, sir.
So now, this DR0 is the ASCII value, but if you look at the actual device communication, now we need to activate some particular pixels.
Yes.
Pixels करेंगे ना?
Yes.
आप क्या कहते हैं इस DR0 को जो होंगे, अब let's assume जो तमाम number of dots होंगे, let's assume if this dot is, now if we have some display, now maybe if this is maybe 7 cross 5 display, 7 cross 5, so it means 7 pixels
And 5.
in row and there are 5 rows
7 and
and
column.
solid columns.
Yes, sir.
7 columns, I mean 7, if it's 7 cross 5, so how many rows are there? 7 rows and how many columns?
5 columns.
5 columns. And which column will be enabled depends on the value
ASCII value. Yes, sir.
and the value of a particular register where it is stored in the data register.
Data register.
Now you have two communication. Now you have a data register. You can have a single data register or you can have
Multiple data
multiple
register.
data registers. Multiple data registers. Okay, now this is from perspective of from the perspective of a single digit. So actually, this data register will communicate with the microprocessor, and now you have some internal, external memory, and now there is some memory. So this is a pixel memory. Pixel memory for whom? For the first letter. Similarly, you can have a pixel memory for second letter. How many pixels are there?
35.
7 multiplied by 5 is equal to
35 pixels.
35 pixels. Now it also depends on the mode in which you are operating the LCD. If it is a 2-row mode, the pixel memory will be large or small?
Small.
Maybe it is 7 cross 5.
And maybe,
And maybe
14
bigger.
cross 5. 14
Maybe it
cross
is
5.
10 cross
Yes, sir.
8. Okay, so it also depends on the mode. Who is determining this mode? Which registers?
Control register.
Control registers. And then these are the data register, these are the control register, and then there is IO logic, and this IO logic is responsible. And now if you want to display these values, now we have 35 pixels. For each pixel it can be represented by 1 bit. When the pixel bit is 1, it means the pixel is on. If it is 0,
Off.
then it's off. Now maybe it's possible for each pixel, maybe you need 2 bit of data, maybe it's 8 bit of data. Why 8 bit of data? Like also if you want to increase the intensity, so now there may be another register of intensity.
Yes, sir.
The intensity. So now intensity, maybe if the intensity is a 4-bit data, so if it's 0, 0, 0, so it is the least intensity, and it is 15,
Most
it is
intensity.
the highest intensity. So electricity also depends on the power. So for least intensity, you will consume less power or more power?
Less intensity के less power.
Less power. And high intensity?
ज़्यादा power.
More power. So it depends on the operating modes. The more features you include in an IO device, the more complex it will be.
Complexity will rise.
More complexity. Now this is, I'm only teaching, we are only considering a single LCD. Now, if you look at your screen, if you look at a screen or your display monitor, Now if you have a monitor, this monitor is typically configured by settings. If you go into setting. So in setting, there is some pixels display, maybe 1024 pixels in this direction and
102.
768 pixels in
This
this direction. So now we have these pixels. Now each pixel is typically represented by 24 bits.
Yes, sir.
Each pixel is represented by 24 bits. So one frame, what is the size of each frame now?
So
In bits.
24 and 768
104
can be
multiplied by
24
768 multiplied by 24
4 bits.
bits. Why 24 bits are required?
कि एक पिक्सल RGB है ना
RGB. So now you have R, G,
and
and B. So this is from 0 to 255. So it is 255, 255, and 255. Okay, 255, 0 and 0.
it is red.
Red. Okay, 128, 0 and 0.
Gray नहीं
Light red.
light red. Yes, sir.
Okay.
Light red.
0, 128, 0.
Light green.
Light green. And now you can have combinations of different colors. Now this is
Yes, sir.
only a single frame. This is only a single frame. But if you are watching a video, to maintain a good video quality, so you have 30 frames per second typically. The typical
Yes, sir.
standard is 30 frames per second.
Yes,
So
sir.
to only one in displaying in a one frame, so you how many data in the 30 frames?
30 frames.
So this is the information you are sending
In 1 second.
in 1 second. And if you look at it, actually typically usually this was the video memory and this video memory. So now you have a video memory. So now this video is displayed by video memory. You have video memory. If you remember, there is some video memory cards, and they are big cards, or some like megabytes, many megabytes of video cards. And each megabytes, and these are frames. So this is frame 0. So what microprocessor is doing? Microprocessor is updating the frames, and VGA is just reading video. VGA, what is VGA? Video graphic adapter. Video graphic adapter is reading from the video frame and is updating this. And based on the intensity of each pixel, this is displayed.
हर पिक्सल तो अपडेट नहीं होगा सर क्योंकि ये फ्रेम है तो उसमें तो पीछे कुछ स्टेशनरी चीज़ें भी हैं.
क्या कह रहे हैं?
लेट सपोज मैं इस वीडियो को डिस्प्ले कर रहा हूँ सर जो मैं यहाँ बना रहा हूँ तो इसमें तो पीछे बैकग्राउंड स्टेशनरी है. सिर्फ ये जो आप मूवमेंट कर रहे हैं
मोमेंट नहीं. अगर देखिए आप वो ये कह रहे हैं कि देखिए यू मे अप्लाई सम कंप्रेशन टेक्निक्स. अगर हम वीडियो की बात कर रहे हैं, अगर पिक्सेल्स की बात करें तो ये जो वीडियो फ्रेम्स है ये तो अनकंप्रेस्ड होगा.
ठीक है
या
सर.
अगर आपके पास कंप्रेस्ड वीडियो तो वो कंप्रेस्ड होगा. You will first uncompress it and then you will display it on the video frame. Video VGA. There are different video formats. कौन-कौन से formats हैं? MPEG format है. So there are different video formats and video codecs for these purposes.
Yes, sir.
Okay. So now if you just look from the perspective of the audio, now this VGA is an output device. It requires a large amount of memory. This memory is then controlled by VGA, video graphic adapter card.
Yes, sir.
And then, who is managing all this stuff? Operating system.
Operating system.
Operating system is doing all this stuff for
Yes,
you.
sir.
And this is visible to the programmer or invisible to the programmer?
Invisible.
Invisible to the programmer. Now let's assume if you are running any program and you say cout in C++ or printf. Okay? Or MATLAB, what's the command to display any characters on MATLAB? Maybe.
I am sure, yes, sir.
Yeah, I am sure whatever actually. Whatever is the data. So it's done by the compiler and operating system. Okay, so all these things are hidden from the programmer. It's abstract these things. These things are abstracted from the programmer. Okay, so now if you look at from the IO device perspective, so now you have control and timings. So the control and timing, it controls the flow of the traffic between the internal resources and external
Yes, sir.
resources. Second, CPU communication. If CPU wants to communicate with the device, it provides a command. IO device accepts the command and perform the required operations. And it is internally managed by the IO device independently. Now, Now it's the device communication, and then the IO logic will communicate with the device. Now you have some device communication, then data buffering. If there are multiple data, now let's assume you have a keypad. You have a keypad. Microprocessor is busy in some task, and you press some keys. Are these keys lost? Sometimes you may have experienced it. Use some types of key, it will not be displayed. It will be displayed after some time.
Yes.
The problem is that microprocessor is typically executing another program, and it's busy in that program. So when something is typed, it goes into the buffer of the IO device. Then it interrupts the microprocessor. Now the data is available in the buffer. When it interrupts the microprocessor, then microprocessor completes its current task. It then jumps to the device and gets the data from the buffer, and then it's displayed. So it also provides some temporary data buffering. Okay, and it also provides some error detection. So the error detection is basically different type of error correction codes can be there. It can be even parity or it can be odd parity. It can be a single error detection or multiple error detection. It can be a single error correction or multiple, depending upon the type of the checksum that is typically used. Okay, now if you look from the perspective of the IO device, there are different type of mechanisms. There are different type of mechanisms. One is program controlled IO, another is interrupt driven IO, and another is direct memory access. So we will study this in 5 minutes. आपको जो मैंने पढ़ाई आज अंडरग्रेड में
कुछ थोड़ी बहुत पढ़ी थी, लेकिन इतने बड़ा पिक्चर किसी ने नहीं दिया था.